Okay, so I'm going to continue our lecture on Chernobyl from this morning. So we've talked about this sort of immediate disaster itself, but after the disaster is what I want to talk about now. So just in terms of numbers, 400 times more radioactive material was released during the Chernobyl explosion than during the detonation of both nuclear bombs during World War II. So 400 times more radioactive material. However, the release from Chernobyl was only about 1/100th of what was released during the entire era of nuclear weapons testing. So when both the USSR and the US and other places were sort of showing off their military might by detonating nuclear weapons in the middle of the desert, in the middle of the ocean, in the South Pacific, all of that adds up to about 100 times what was released from Chernobyl. The fallout from Chernobyl reached all of the European countries except for the Iberian Peninsula. Pripyat, the city of Pripyat, which is near Chernobyl, is still uninhabitable, and the environmental effects are widespread, and we're going to talk about that in a second after this. 50 workers ended up dying from acute radiation syndrome, and thus far, 15 children who were in the vicinity have died of thyroid cancer to date. Among the people that were evacuated, 200,000 of them were emergency workers and 350,000 of them were evacuated. And official expectations are that about 4,000 of those folks will die from radioactively caused cancer, thyroid cancer, for example. 4,000 cases of thyroid cancer have already been reported, but there's a pretty high likelihood of survival of this particular type of cancer, as evidenced by some official government numbers from Belarus. And these are just the official estimates. So the unofficial estimates are, of course, that many more people have died due to this fallout. We'll never know the exact extent because it's difficult to sort of be like, this was because of this, or this wasn't because of this, or whatever. So keep that in mind when people throw around numbers. Okay, so here's Chernobyl, right here. If I can find it, yep. And this is today regions where radioactive material has been measured and are now off limits in various levels of control. So we have this sort of closed zone in the dark red here, the permanent control zone in the dark pink, the periodic control zone in the brownish orange, and then the pink is the unnamed zone. Okay, so these are varying levels of government control over restricted access, who can live there, etc., etc. Right. Here's a look at the radiation dose across Europe on May 3rd, 1986, just a couple days after the meltdown. And the numbers are presented in however much times the normal rate of that particular radioactive material there is present in the atmosphere or in the environment. Okay, so there's always radiation in the environment from the sun, from other activities, right? So this is how much more there was due to the fallout. And so you can see that around the area of Chernobyl is up to 100 times more radiation than is normally found. So that's a lot, and that's likely to cause a lot of problems. And then looking at the soil or the ground, this map here shows where the cesium, the radioactive cesium, which is just an atom, it's an element, was deposited in the soil, right? And that's going to affect both the plants growing in the soil and the animals eating those plants. So you can see that it's quite extensive, pretty far from the actual Chernobyl explosion, which was here, right, all the way into Belarus and parts of Chernobyl. So, Ukraine. So, and this is still a problem today. There's still cesium deposited in the soil today. So these next few slides, which talk about some of the effects, have some images of the Chernobyl of today, the Pripyat of today, and they're quite eerie. So I leave them up here because I think it's also a really interesting sort of case study in like how nature can reclaim what was once theirs, and whether reclaiming is the word we want to use, or whether it's nature is rebounding, or a new nature is forming, a new world is forming. These are all concepts that I want you to think about, not just in this particular case, but throughout the rest of this course, is like, what is the role of nature in mediating these environmental disasters? So right after the explosion, an exclusion zone was set up, which was originally called the Chernobyl exclusion zone, and was just this 30-kilometer radius around the Chernobyl power plant. As more data came in over the years, over the decades, the exclusion zone has been renamed the Chernobyl nuclear power plant zone of alienation, and is actually now, the boundaries of it are this brownish color region here. So that's the new sort of Chernobyl exclusion zone. You can still see the old power plant through the woods. The woods has reformed during this. There's no people living in here, right? And visitation is very severely restricted. Here's the entrance to the exclusion zone. What that looks like is very heavily guarded on all sides. And so a forest has regrown, but you can actually still see the power plant, which has essentially been left sort of untouched. So after it was discovered that there was an explosion and the reactor had blown up, a number of different efforts were underway to bury the reactor, actually, to cover it and contain any of the nuclear waste that was still remaining in that reactor. And there's quite a bit of it, actually. And I have a picture of coming up of what they built over it. But what they did build over the reactor is now known as the sarcophagus, and it's a large cement structure that was constructed over the exploded reactor. And then the rest of the power plant was just essentially left untouched. They did build a concrete slab under the power plant as well to prevent a meltdown from melting through the ground into the groundwater, and that may have saved millions of lives, actually. Though it risked the lives of the folks who built it very substantially. Okay, so immediately following the meltdown, everyone's looking on the weather. Where's the radioactive cloud going to go? Is it going to rain out? What countries is it going to affect? So the radioactive cloud obviously moved over Sweden first, as we talked about this morning. Sweden was actually the country to identify that there was a nuclear meltdown, a nuclear explosion at Chernobyl. They traced the plume back to Chernobyl, looking at the weather. And then the day after that discovery, and then the day after, they alerted the international community. On April 29th, Sweden advised people not to drink any rainwater, and to prevent any cattle, both for milk and beef consumption, from grazing on the grass. Because remember, the grass is growing in soil that's receiving this radioactive material, and also the radioactive material itself is falling onto the grass, depositing onto the grass, which the cows are then eating. So here are some maps of where iodine-131 and cesium-137, which are both harmful byproducts of an explosion of this type, looked like in May of 1986. You can see right around where Chernobyl, where the explosion was, the concentrations are, of course, the highest, but they are also relatively elevated throughout much of Europe. Again, the Iberian Peninsula here, Spain and Portugal, were largely spared just due to the way that the weather, the rain clouds were moving. But most of Europe received large deposits of cesium-137 and high concentrations of iodine-131 in the air. You may have noticed that, may remember that in the video that the doctor asked if they have any iodine tablets. So one way that you can limit the harmful effects of radioactive material on your body is to take an iodine tablet, which neutralizes the radioactive iodine-131 in the air. And so it's very critical, if you are exposed to radiation of this type, to take iodine tablets to prevent harmful effects and potentially cancer down the line, that sort of thing. So the Lapps, the Finnish and Swedish and Norwegian folks were particularly worried about reindeer feeding on contaminated lichen. Again, it's falling sort of on the ground. After the plume of radiation moved over Sweden, it came back and moved over Austria and France. The Austrians imposed very strict restrictions on consuming vegetables and milk, and the French abstained from imposing those restrictions. And again, here are some more photos, an especially creepy photo of a doll here, and then the Chernobyl power plant itself. And you can actually see the sarcophagus here, which has been constructed over the blown up reactor. Here are some more maps showing those two plumes. So the first plume moving over Sweden and Finland, and then the second plume moving over Austria and France. This is the radiation contamination, cesium-137. Again, cesium-137. These are all similar maps. They're actually the same data, just presented in different maps for folks. So you can see that here's the explosion, first plume, second plume, third plume. And this is the general direction of the air from west to east. And so all throughout this sort of eastern Russia region here, you're going to have high radioactive material depositing and in the air. So I mentioned the sarcophagus. So the sarcophagus is what they built over the blown out reactor. So if I look at it, this is what it looks like. Aesthetically, it's brutalist. It's a very brutalist aesthetic construction. This is 1986 USSR, right? So made from concrete. Hopefully will protect that radioactive material that's still contained within the reactor. So if we look at a cross section of the reactor here, which I think is really, really, really fascinating, you can see that it sort of exploded here, right? So this would have been the reactor. It exploded and fell into this hole here. This is the bottom of the reactor where a lot of the nuclear reactions would have been taking place. Just above the ground, right? So the ground would be somewhere, where is it? Here. So just above the ground, this is where you have a lot of the nuclear reactions, the chain reactions happening. And they literally just built a concrete sarcophagus to cover the whole thing. So actually inside of the sarcophagus is still quite a bit of very volatile radioactive material. And you can see that a lot of it began to leak through and actually melt through the bottom of the power plant itself. So they constructed a concrete slab under the whole reactor, okay, to prevent that nuclear waste from melting all the way through down into the groundwater. So the sarcophagus really is an entire concrete encasement around this blown out reactor. And here it is, and it's still there. And this stuff in there was going to be reactive for thousands, if not up to 1 million years, right? So the concrete has to hold. Okay, as I've mentioned, it's now been 35 almost years since Chernobyl, since this explosion happened, and nature has refilled back in the exclusion zone. There's no more people. So you can see here's a comparison photo of, like, you can see the town of Pripyat, and then you can't see it anymore because the forest has regrown in its place. And so I want to show two videos. One is a New York Times video, and one is the end of the Our Planet Forests episode, the Our Planet series on Netflix. They have an episode on forests, and the last 5 minutes or so is on Chernobyl. And so I'll stop talking, and I want to show those. And then I want you to think about it, and I want to have a conversation about what it means for nature to return to a place. And you know, we're going to have this conversation tomorrow, and I really want you to think about it. I'll give you some guided instructions on what to do with that. All right, so let me go to, so this is the first video here.
All right, well, it looks like a nice spider web over here. Let's see if we can't catch this on film. We missed it up a little bit. You know, what was invisible now becomes visible. Nice. Yeah, that's perfect. Yep. Yeah, this one's sitting in being bathed in about 45 microsieverts per hour, plus or minus, which is pretty darn radioactive.
1986, an explosion and fire at the nuclear reactor in what was then the Soviet Union in Chernobyl, Ukraine, launched a plume of radioactive fallout that rendered a large swath of the region here uninhabitable. Since then, the creation of a 1,000-square-mile exclusion zone prohibiting human activity has led some to declare the area a restored Eden, brimming with wildlife. But for more than a decade, Timothy Mousseau, an American scientist, has conducted an extensive biological survey here, and his studies have shown that life has been far more slow to recover than previously believed.
It's a perfect area for biological studies because we see a diversity of plants and animals. It's one of the hotter areas in the Chernobyl zone. And so from our previous work, we know that this level of chronic exposure is above that most species will tolerate.
So cute.
This year we've been looking at the small rodents, we've been looking at spiders. Earlier this year we were here working with the birds. We found that the abundance of many species of birds are depressed in these areas of high contamination, leading to an overall decrease in the biodiversity on the order of 50% fewer species in hot areas than there should be if there wasn't radioactivity in the area.
Mousseau says he has seen much higher frequencies of tumors and physical abnormalities, like deformed beaks among birds, compared with those from uncontaminated areas. He has measured declines in populations of insects and spiders, and yet in a recent paper released last month, Mousseau has also shown that some birds here may actually be adapting to high radiation levels.
So these are special digital audio recorders that are designed to pick up the high-frequency sounds that bats produce while they're echolocating and flying around and trying to capture insects. And by the frequency of calls, we can get an idea of the abundance of bats. Yeah, look at these mushrooms here. See if it goes up. Well, look at that, eh? 43. So 42, 43. So, this mushroom's definitely much hotter than the surrounding areas.
The legacy of Chernobyl, Mousseau says, can be seen not just in animal life. Cut trees here show a dramatic change in the color of their rings, exactly in 1986.
It occurred to us after visiting Fukushima last year that some of those spider webs looked a little strange. And so we thought we would test that hypothesis in a very scientific way by capturing images of as many spider webs as we can find in hot and cold areas of the same kinds of species, to see if there's more variability or less structure to the webs in these radioactive areas. It could serve as a biomarker of the background radiation. We're in the town of Chernobyl, downtown Chernobyl as it were, and what we found is that the frequency of aberrant color patterns on the backsides of these bugs is directly proportional to how radioactive the area is. The one on this side is relatively normal, and then you look on the other one and you see that the black spots are kind of fused together. Thank you.
Mousseau's work in Chernobyl will continue for years to come. He's extended his study to Fukushima, Japan, and hopes to shed a brighter light on the lasting effects of radiation on biological systems, including humans.
Buying a car from Vroom is so easy. All you need is a phone and a finger.
Okay. And now the Our Planet video. Okay. So that's that, and a lot of different views and things to think about. And so I want to talk about this idea again of nature reclaiming, blah, 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 during the next class. Okay. Thanks.